Alright, here is a video on the review practice problems, and you can just look at these first few. Top-down design, basically taking a big problem, breaking it into smaller chunks, breaking that into smaller chunks until they're manageable tasks. Abstraction is hiding data that is not relevant, hiding details. I said functions are a great way to do this in programming. What's the purpose of commenting code? Makes it easy to read and understand for other people, helps find bugs and errors faster, gives an overall idea of the functionality. This is what a single line comment looks like with a hashtag. This is what a multi-line comment with 3 single quote marks above and 3 single quote marks below. I could have written as many lines as I want. These only work for one line. And then why do we write functions? Basically, they're used to break things down into smaller tasks. They keep you from having to repeat the same thing over and over again. And eggs, hold on, I'm spinning. Okay, and they're used for abstraction, so your code doesn't get all bogged down with stuff. And then it says here, write a function to walk 2 spaces forward and then face south. So you could do, I guess if you assume we're facing east to begin with, like we usually do, you could say, I just named it whatever, do move, but I write def, I say this, I use parentheses, I use a colon, and then I have to say move forward, so we'll do indented, say move, move, and then here you could just say turn right if you want, or I could be really fancy and say while not facing south, and then indent it and say turn left. Basically what that does is make sure I face south, because while I'm not facing south, it will turn left. It'll check it again. Am I not facing south? Keeps turning until you are facing south. That's a really fancy one. You didn't have to do that if you made an assumption we were facing east to begin with. So write a function to make Carol go up a stair step. Assume she's facing east to begin with. So we got our dog kind of facing that way. Then imagine you have a stair step. So I don't know how many steps we're going to go up, but we'll just do one stair step. So maybe I got a function def step up. Maybe I'll write that one, def step up. And we're going to go, let's see, turn left. And then move. And then turn right. And move. And that goes, okay, left would go move, right, move. Now I'm on top of this step, facing that way again. And you could repeat that as many times as you want if you knew there are stair steps there. So then we go down here, use your function, assume it works, to help you write code that'll take Carol up any size flight of stairs, regardless of world size. Stop climbing if there's no room above, no room in front, or if you would walk off a cliff. That'd be bad, to walk off a cliff. We don't abuse animals. Okay, so here, I don't know if I can use this the way it is, because it doesn't check about walking off. Shoot, man. So it would be pretty easy with a while loop if that just worked. Maybe I made a little mistake here. So let's say I had... So let's assume it's kind of like this, a normal stair step. We'll do wall front is clear move, because I don't know if I'm standing in front of the steps. So all this does is get me to the steps. Okay, so get to the steps. Oops, it's not a multi-line code. Should have just written that next to it. So that'll get me to the steps right here. We can be facing east. And then, since I didn't know what world size it was, or if I was right in front, maybe you didn't put that line of code in. But then I need to, go up one step, and then I need to see if there's another one there. So I don't think I can use that step up because I got to check on each thing. So I'd be like, I have to move up and turn right and check if there's even a space there. Okay, so now we're going to do this. I think we need to write a function for this. So here's what I'm thinking. I think I got to change my code up here. I don't get to use this, gosh darn it. Here's what I got to do. I got to first go up here, scout if there is room in front, if there's a wall there. Because if I was up here, if I was already standing here, and I go up and look right, it's gone. I also need to see if there's a ceiling above me. What if I'm like right here maxed out at my ceiling? So I think I need to first check if I even can move up before I do it. So what are we going to do? While, here we go. While above me is clear, because I don't want to keep moving if I hit the roof. So what's the above me is clear? That would be left is clear? Yeah, because below was right. So while left is clear, so as long as above me is open, I'm going to go through this cycle. Let's get up to here, because that'll make sure. I'm going to turn left. And then I'm going to turn right. Wait, turn left, move. So now I'm up here. So I turn left, I moved. Now I need to see if there's space for me to go. So if there's space, I'm going to move forward. If there's no space, I think I need to go back down. Okay, because I already knew what this is going to avoid is me jumping off a cliff. No? Me running into a wall again. So this would avoid a situation where you're going up steps and then you got a wall here and you're done. So let's say I was on this step. Above me is clear, so that part worked. I go up here and I look over, and if that's blocked, I just go sit back down. You sit, boo boo, sit. So here we're going to say if right is clear, because I'm going to be facing up and below me is right. If right is clear, we're going to turn right and move. Oops. Okay. And then I got to say else, if it's not clear like this situation, I just need to go back. So I'm going to pause this, write a little function for go back off to the side. You have to put your functions up top. But I'm going to do that so I don't waste time here. Alright, so I wrote this function go back. So this is if I went up and I saw there was a wall there. So that's the else part. I would say go back, which is just turn around, move down, turn left. And that gets me back. So now I dealt with up here. This is only while you're not running into the ceiling. This one deals with not into a wall. And we haven't dealt with not jumping off a cliff yet. So let's see what that looks like. So I draw these out. Okay, let's imagine Carol's up here. I'm facing this way. Here, the top is clear, so it would go through here. It would pass that. So you'd turn left and move. So I'd go up here, and then I'd look over. And then front is clear. Ooh. I should put, I guess I need to squeeze something in right here. I should write a function that checks the right. So if above me is clear, I should also check if in front of me is clear. Alright, so I'll write that in a separate one, come back so I have time to do the last one. I think I figured out a quicker way. Instead of checking for a cliff, like I was doing, I say squeeze in here a while front is clear and indent all these, and then you won't go off a cliff. There you go. Alright, so that other problem was a little harder than I intended, but that's what happens when you make up a problem on the spot. I thought it would be easier than that. I probably shouldn't have put all those restrictions. Or told you what kind of staircase. Anyway, let's do this one. This one is a known amount of distance. You start facing here and you got to put all these things on. So basically, if I try to think it out, I want to make one loop and then I'll do it 6 times, and I'm just going to alternate between putting a ball down, coloring it blue, putting a ball down. And it doesn't matter if I paint a blue square more than once. So let me define a function that will just take one lap. Actually, let's do one straightaway. Okay, so for a straightaway, imagine, I think my first thing will be to move once, right? Because if I move, now I'm sitting right on this square here. And I'm going to start my put a ball down, move, paint this blue, move, put a ball down, turn left. We've kind of done one like that. So this will be definition for one straightaway. So we'll call it straight. So for straightaway, I will put ball. Ooh, do I want to put ball? I'll have to think about that. Let me think. Alright, I think I don't even want to do this, so I don't think I need the move part. I'm going to do, while front is clear for the first one, and get down here, and then I can move, you know, a couple spaces, put one down at the end, turn left. Move a couple spaces, put one down at the end, turn left. Okay, let me do that. So I'm not going to put a ball down first. I'm going to get all the way to the end. So we'll say while front is clear, and then I'll move. So that just gets me to the end. That actually moves me all the way to here. And then I'm going to put ball. So I'll move it outside. Watch where my indent is. I'm intentionally not indenting this. Alright, change of plan here. This won't work, I realized, because front is clear would take me to each corner. So I don't want that. I want to just move forward a certain amount of spaces. So I think I liked my first idea of one move. I'm going to change my def here. Let me do that and then come back on. Alright, so here we go. I've got it going here. So the first move is here. We move forward to this spot. And then I want to call my first loop. So I will 4 times, so I in range 4, I will move forward 1, and then I will paint my spot. So I'll paint my spot blue. Then I'll move to this spot, put a ball down, turn left. And it goes around 4 times. And then I call that 6 times.